Hi, so last video we created a layer structure that will allow us to sketch very simple rough lines, have Grasshopper read them, and return information to us about them. And so what I did was sketch out a very basic set of shapes on the ground floor layer. So at the moment this is all happening at level 0. Now what we're going to do in this video is make it so that the wall lines and the division lines are read by Grasshopper. It creates surfaces for each of them, calculates the area, then displays the area in real time on the sketch, which means that while we're sketching, we see the exact areas of all the polygons that we're sketching. So let's just open Grasshopper. And we're going to start by creating a geometry pipeline for 3 different layers: the wall lines, the division lines, and the voids. So you have to type in the exact layer name here and it'll read it, and then type in the type of geometry. So it'll just be curves. And then it will have read all of the information in that layer. So this will be division lines, and this will be void. And this won't be curves, this is going to be points, and we're going to see how that works a bit later. So that's the information that we're working with. Next, whatever comes out of here, I'm going to want to split it. Now both the wall lines and the division lines for this part of the exercise are going to go into the same operation. So the areas are going to be calculated whether you draw division lines or wall lines. Later we're going to want to make a differentiation, because wall lines are going to be used to draw walls, whereas division lines are not. But in this case, they're just going to go to the exact same place, and we haven't drawn any division lines, so there's nothing there. And this can be flattened. So that's all of the curves in every layer, called wall lines and division lines. You can actually see them highlighted here. So what are we going to do with them? We're going to use all of these to split a large surface that's much larger than the bounds of this drawing. So in order to do that, it's just easy to take any point that lies on here, just take the start points, and then just take any start point that you want, just as long as it's just one, because we only want one surface. And then use that to create plane, which we're then going to use to create a large 4-sided polygon. Number of segments, we want 4. And then for the radius, we actually want to enter something really, really large. So if we just write 1000, because I'm drawing in meters, and I want to try to keep all of my parameters here, just because you don't want to be traveling within the definition to find all of the sliders and inputs that you need. So I try to, everything that you need to establish, I try to move it to the left. So just have that as a radius. And then if we zoom out here, it's created a really, really big surface, much bigger than anything else. And that's what you want. If you're drawing in millimeters, well, you're just going to have to add a couple of zeros there. Just make sure it's much bigger than your drawing, and then your drawing's within it. So, okay, that is going to be used to make a surface. And that surface is going to be split by all of the curves. Oops. So now it's made a series of surfaces. Now, the only thing we want to do now, in order to move forward from this step, is just take the largest surface, which would be all of this leftover space, which is a single surface, and remove it. So let's just measure the area for each of these, then sort the list of areas from smallest to largest, and consecutively sort each surface. Then you want to reverse that so that the largest surface would be first, and just eliminate surface with index 0. And there they are. So just hide everything else. And we've got our surfaces here. Just group this and call that split surfaces. So these are the surfaces that we're going to be working with. And you'll notice that I can move anything here, and the surfaces are getting recalculated, retrimmed as I draw. Now, we may not want all of these surfaces to enter into our calculation. Some of them may be voids. So what we want to do now is for each surface that is touching a point placed in the voids layer here, I want to remove that surface. So let's just add a point on the voids layer. There it is. Now that's going to be read in here. Now I've got a single point here. But actually, what happens if I don't have any points? Remember that since this is a tool that we don't really want to be modifying this script, and we want this tool to work in all cases, we have to add a point there always has to be one point, otherwise the script is going to freak out. And an easy way to do that is to add a point from our very large polygon here. Just get a start point here. And make sure we add that to whatever we're doing here. Just merge it. One of these, this one point, and here. You might want to flatten this. Okay, so everything that's touching, every surface that has a distance to any void point of 0 is going to be removed. So we simply have to take each of these surfaces, and we're going to want to graft this here. And the component that measures the distance of a point to a B-rep is here. So take the surfaces here and input the points here. Now every single point that's in a layer called void, its distance is being measured to each of these surfaces. So there's 2 points, and you can see in the file structure that each surface is being measured from 2 points. So we just might sort these according to distance. choose the smallest distance and ask whether this is 0. However, sometimes Grasshopper is really weird about whether something is 0 or really, really close to 0. And sometimes it doesn't detect that it's 0 even if it is. So what we're going to do is ask it, is it greater than a very small number? So I'm drawing in meters, so I'm going to use a number like 0.01. So that would be the tolerance. And so we can just use that as a way of removing every surface. We'll just take them from here. Every surface that is touching a void point gets removed. Let's just hide this. Actually, let's hide all of this. Preview off. And there it is. As soon as I draw a void point here, it removes the surface. I move it, and that surface gets removed. I can copy it. And all of these are getting removed. So the goal here is making a tool that works for speed so that you can just minimize this and just add points as you see fit. Sorry. And be able to draw and get information back really quickly. So we're going to call this part eliminate voids. Now, after we've got the set of surfaces that we want to analyze, we're just going to add an extra step where we take each of these surfaces and first, if we removed something, there's an empty branch. You can see it there. That's 0. There's a branch with nothing in it. So we want to clean that up. And using clean tree, this component is able to remove empty branches. So you just, there's remove empty branch option and set boolean true. And there it is. It's removed all of the empty branches. And now these surfaces, we want to explode them and take all of the edge curves and join them. And also try to use simplify curve. That's just going to allow us to remove any errors that were made through splitting, because splitting surfaces can get quite messy. And so, for example, you can see that one of these polygons actually has 17 sides. That doesn't really make any sense, does it? So we simplified it, and now it's got 4 sides. And now just using this, we'll make new surfaces from this. Again, it's useful if we just hide the steps that we've been going through. Just testing for errors. So group that. Let's call it rebuild. Now, finally, what we want to do is we can already read the areas for each of these surfaces, but because we want to display them in the most convenient way possible so that it's really useful when we're drawing, we want to know where to display all of this information. And you can see that this component, this gives us the area and the center point. But if we display the area as a number at each of these points, then we have a problem where, say, I've got this area and it's intersecting with this area, and suddenly I'm going to get two areas being displayed here. And those little mistakes add up and make this tool really messy. So what we're going to do is we're going to find a new way of calculating the center point. And it's actually not that difficult. It's not as simple as this, but it's not difficult. What we want to do is for each of these surfaces, calculate a list of points on it. 10 by 10, it shouldn't make it too slow. You want to have a good range of points, and it's going to select the point that's farthest away from any curve. So actually, this component does something that's not really useful for us right now. It makes rows and columns into branches. So you've got, 11 branches with 11 points on it when you want just 100 points in one branch. So actually, first all we have to do is shift the paths. And now we've got 121 points corresponding to each of these surfaces. So that's great. And there's a component that will measure the distance of each of these points to each curve. Now the curves are here, not the surface. So there we are. And now this distance, we can just use it to find, again, by sorting, the point that's furthest away from the curve. So here we go. Here is the list of distances that's been sorted, and we want to sort the list of points synchronously. And because it goes from smallest to largest and we want the largest, we just reverse this list of points that have been sorted. Take the first one, and if I hide this, the problem that we used to have, see, the points get reconfigured every time you're moving. So this point that was here moves over here. And that's exactly what we want. It's always shifting out. And so that's going to be the way that we're going to calculate. Oh, let's just group this. Keep it neat. We call it find center points. Now the center points are going to be used to create planes. Planes are going to be used to display text. It's over here, 3D tag. So the location, you want that to read the planes. The text, we want the text to be the area. So we do want to read the area off each of these. But because it's an area, we also want to turn it into an integer. So let's just do this. And since we're drawing in meters, the default size of 1 is perfect. So there it is. It's displaying the size of each of these. And if I remove this void, it's displaying that area. Now, the cool thing about this is that I can just minimize this and start sketching to my heart's content and start sketching more wall lines any way that I want, and it's splitting everything up. Everything that I alter here is going to alter the result. Now, you can get pretty creative with what you can do. See, all of these have their own areas and all of them are being calculated in real time. So you can move any point, doesn't matter the geometry. And you can get quite Libeskind here if you want. And everything is getting updated in real time, so you have a real sense of what type of spaces you're creating. And this is a real lifesaver in, say, maybe a competition where every, bathroom is specified to an exact area, and this is perfect. And this not only works with, polygons. I could sketch with any type of curve that I want here. And it's working everything out in real time. So again, the goal here is to create a tool that gives you feedback in such a way that it becomes much faster than drawing in, say, AutoCAD or Revit, where, yes, you can get all this information, but you're not tailoring the tool to your needs at the moment. This is a tool for conceptual sketching in a really, really quick, intuitive way. So this is the first part of what we've done. We've just created a real-time readout of all the areas in our sketch.